Hello, my name is Alay Patel and my student roll number is ECM23002. So, in my director research project, I had chosen a topic construction, scheduling, and planning of mixed use building in metro cities, overcoming through technological innovation and strategic best practices. Rapid urbanization, population growth, and the pace of technological advancement have significantly impacted the construction industry, especially in metropolitan areas. Completing projects on time, within budget, and the desired quality level now requires smarter scheduling and strategic planning. In metro cities, this task becomes even more complex due to space constraints, traffic congestion, and strict regularity frameworks. The need for this study arises for growing demand for smart city planning and the urgency to address urban construction challenges through innovative approaches. Technological advancements such as building information modeling, artificial intelligence, and the Internet of Things are playing a crucial role in enhancing planning accuracy, improving coordination, and enabling real time decision making. At the same time, lean construction practices help reduce waste, lower costs, and foster better collaboration among stakeholders. Integrated project delivery further support these goals by involving all key party owners, architects, contractors, and suppliers early in the project. This collaborative approach promotes shared responsibility, streamlined communication, and a stronger focus on timely and cost-effective project completion. Together, these strategies provide a comprehensive framework for overcoming the unique challenges of constructing mixed-use building in metro cities. So, coming to the research analysis, construction scheduling means planning and managing when each part of a construction project will happen. It helps make sure tasks are done in the right order, on time, and with the right resources. In cities, this can be harder because of tight spaces, busy roads, and strict rules. Moving on to technological advancements that are improving the construction process, we have several key innovations. BEAM enables 3D, 4D, 5D planning, helping visualize, scheduling conflicts, and improving coordination across mechanical, electrical, and plumbing system. It allows for seamless integration of different construction elements, ensuring higher accuracy and efficiency. Artificial intelligence play a crucial role in predicting delays and resource shortages based on historical data. By analyzing vast amounts of data and can optimize project timelines and resource allocation that helps to mitigate potential issues before they arise. Then coming towards Internet of Things, it enables real-time tracking of materials, equipments, and workforce, which leads to improved project monitoring and management. Another is lean construction. It focuses on waste elimination by identifying and removing non-value adding activities such as overproduction, rework, delays, etc. This innovation helps improve overall project efficiency and cost effectiveness. Now focus on some of the major challenges faced in the metro city construction, which is space constraint. As urban areas continue to grow, the scarcity of land, the cost of construction, and makes site preparation more difficult. Limited space also complicates the planning and execution of various construction phases. Coming towards the traffic and accessibility, metro cities often experiences delays due to traffic congestion and limited access to construction sites. These delays not only slow down the construction process but also add significant costs to the project. Another is regulatory and permitting issues. Strict building codes, zoning laws, and complex permitting process can significant cause delays in construction projects, with compliances of regulation often involves lengthy approval processes which can impact the timeline. Another challenge is of safety concern. In metro cities, ensuring the safety of workers and the public due to dense population and complex transportation system. Implementing effective safety protocols is crucial to minimize risk and ensure workers' protection on site. Another challenge is insufficient stakeholder support. Many projects suffers from a lack of involvement and commitment from key stakeholders. This leads to poor planning and miscommunication, which can result in delays and budget overruns. Poor decision making on activity critically, which is inadequate training of project teams in managing schedules, often results in poor decision making. Mismanagement of critical activities can cause delays and further complications in the project timeline. So, coming towards the literature review, interviews and case studies that can conduct semi-structured interviews with a diverse group of industry experts, including project managers, engineers, technology specialists, and urban planners. These interviews are crucial as they provide first-hand knowledge of the challenges and best practice in implementing technological innovations and strategic planning in construction projects. Data organization: all the data collected from the interviews, case studies, and surveys will be systematically organized and coded. The interview transcripts will be transcribed verbatim to capture every nuisance of the discussion, ensuring that no important details is lost. Coding process: to analyze the collected data, an opening coding approach will be employed initially. This method helps identify significant statements, phrases, and concepts related to construction challenges and the application of technology. While this study aims to provide valuable insights, it is important to acknowledge the following limitations that may impact the finding. Geographical scope: the research is focused on construction within metro cities. As such, the findings may not be generalized to the rural or suburban. Subject in qualitative analysis: the research heavily relies on qualitative methods such as interviews and case studies. While these methods provides in-depth contextual insights into the experiences of professionals in the field. Coming towards the technological dynamism, the construction industry is undergoing rapid technological advancements, which means that the findings of this research represent a snapshot of the field at a specific point in time. So the methodology and limitation outlined here are crucial for understanding the scope of the research and ensuring that the findings are interpreted with the right context. In this section, we will dive into the data collection processes, focusing on the challenges faced by the Ahmedabad Metro project, which aims to alleviate traffic congestion and enhance urban mobility in the city. The Ahmedabad Metro project has faced several significant challenges that have impacted its progress and success. These challenges have been divided into primary categories: land acquisition and environmental concerns. One of the most pressing challenges has been opposition from the residents and shop owners, particularly near areas like Thaltej Gram and Jivraj Park in Vijalpur. These areas are crucial for the expansion of metro, but acquiring land has proven to be difficult due to community resistance and environmental concerns. This has led to delays in the early stages of development. Financial and operational transparency: investigation have uncovered some financial irregularities with the project. For instance, fraudulent procurement practices and wasteful expenditures have been reported. Several causes have been identified that have been contributed to delays in the project. That is resource availability and allocation. Another is unrealistic project scheduling. Third, complexity of site management. And last is lack of proper monitoring. Coming towards the vertical tracking sheet, this is a crucial tool used to monitor the progress of a construction activities on various floors of the project. The sheet tracks both the floor, the baseline and actual duration of each floor, showing the expected start and finish dates along with the actual values and any delays encountered. Tracking duration, for example, the 16th floor was originally scheduled to finish by 11th November 2025. However, due to delays in certain phases, it is now expected to finish by 15th November. The pour cycle is another key element being tracked, ensuring that concrete pouring is happening according to schedule and any delays in the pouring process are captured. For example, the seventh floor has a total delay of 10 days, highlighting the need for better coordination in pouring process. By carefully tracking the progress of each floor, this sheet helps project manager pinpoint specific areas where delays occur, whether due to resource allocation, scheduling, or other factors, allowing for targeted interventions. This slide highlights the data collection process and presents key insights from the survey conducted across various metro cities. The survey aims to identify common cause of delays in construction projects and understand the methods used for planning and scheduling. Additionally, we have included suggestions from industry professionals on how to improve planning and scheduling process in construction projects. Coming to the causes of delays, the table on the left lists 15 potential delays caused each axis for probability and severity on a scale of 1 to 5, where 1 indicates low impact and 5 indicates high impact. Here's a summary of the key findings. Poor site management. This is the leading cause of delay with a high likelihood and significant severity. Proper site management is crucial for minimizing delays caused by inefficient scheduling, poor coordination, or inadequate resource on site. Unrealistic project scheduling, scheduling that does not account for real world constraints, lead to major setbacks. The impact of this delay is high as it can affect all stages of the project, including budgeting and resource allocation. Then another is labor absenteeism. The second most severe issue identified, though less frequent among workers, lead to significant delays in meeting deadlines. It emphasizes the need for proper labor management and contingency planning. Another is design changes and rework. One of the highest severity delays design changes during construction leads to major disruption. Adjustments to the design cause significant rework, resource allocation, reallocation and time extension. Late delivery to construction material. Material delays were identified as a significant cause of the project delays, stressing the importance of having a reliable supply chain in place. Poor communication and coordination between all stakeholders is essential for timely project completion. Poor communication often results in misunderstanding and delays. The table summarizes this cause and their impacts, showing that design changes, labor absenteeism, and poor site management are the top contributors to delays in construction projects. Coming to the survey results, geographic location, the survey covered several cities across India to understand the regional differences in construction management. Ahmedabad emerged with the highest number of the responses, which is 12, indicating a higher level of engagement or challenges faced by the professional in the region. Other cities like Mumbai, Bangalore, Gandhinagar, and Madhya Pradesh had fewer responses, but their results still contributed valuable insights into the delays. Coming towards the method of planning and scheduling. This Methods used for planning and scheduling in the construction projects across different cities. Majority of respondents, 11 uses specialized software like Primavera or MSP for planning, showing that the technology is playing a significant role. Basic tools like Excel were also used by several respondents, like 4 from the survey. Interestingly, manual paper-based methods are still used by a small number of respondents. One respondents only use paper-based methods, which highlighting the ongoing reliance on traditional methods. These show a clear trends towards digital tools in planning and scheduling, though there are still some areas there where manual methods are used. Coming towards the suggestion for improving planning and scheduling. Improved communication was ranked as the most important suggestion with 16th response, highlighting that better communication between teams that can help prevent delays due to mismanagement or misunderstanding of project goals and timelines. Better software tools was the second most popular suggestion, emphasizing the need for more sophisticated tools to manage complex projects and its efficiently. More training for planners also emerged as significant recommendation, pointing out that ensuring planners are well trained in using advanced scheduling tools can significantly improve accuracy and reduce project delays. Realistic time estimate and improved resource allocation were also identified as the key strategies for enhancing project timelines and minimizing delays. This slide covers the key technological innovations in construction scheduling and best practices for effective planning. Advancements in tools like Primavera, Microsoft Project, and Beam have significantly improved construction project management, real-time data, and predictive analytics. These tools allow for real-time tracking, predictive insights, and early identification of risk, help minimizing the delays. Enhance collaboration. Tools like Beam improve communication among stakeholders, optimizing workflows, and reducing miscommunication. Best practice for effective scheduling and planning is risk management and contingency planning. A strong risk management plan with clear contingency ensures delays or issues are handled without detailing the entire project. Continuous monitoring and evaluation, regular adjustments based on real-time data help keep the project on track and identify potential bottlenecks early. Time coupling method, a unique method for scheduling and planning to comprehend and control the temporal interdependence between various tasks and activities within a project. Coming towards the difference between Primavera and Microsoft Project. Primavera, it is specially designed for large complex projects. It details but expensive and integrates with other enterprise systems like ERP, MSP, affordable and effective for general purpose project management with basic scheduling and resource management features. It integrates well with Microsoft tools. In this section, I will walk you through the methodology used in our research and how it contributes to effective project scheduling. Methodology overview. Our research methodology follows a structured approach to gather and analyze data related to construction project scheduling. The step includes literature reviews. We started by reviewing existing research articles and case studies related to project scheduling to understand the established practices and challenges. Then, case study analysis. We examined real-life construction projects to identify common scheduling issues and solutions applied in those projects. Then interviews with professionals, discussion with industry professionals, including project managers and planners, helped us gather insights into practical challenges and best practices in scheduling. Site visits, on-site observation provided a deeper understanding of the real-world applications of project scheduling techniques. Then coming towards then data collection, we collected data from various sources, including site reports and project schedules, to identify the trends and areas of improvement. Comparative analysis of delays. We compared delays across different projects to identify recurring issues that affect project timelines. And the last way is suggestion for good practices. Based on our findings, we propose best practices. We to enhance scheduling accuracy and efficiency. Coming towards the project scheduling, effective project scheduling that involves defining how long each task should take, coordinating tasks, and ensuring that resources are allocated efficiently. Scheduling ensures that project is completed on time by organizing tasks, acquiring necessary supplies, and managing personnel. Reducing task conflicts. A well-organized schedule reduces the likelihood of conflicts between tasks that could impair project performance. Coming towards the methods of project scheduling. Let's look at how various scheduling methods are applied in construction project management. CPM, critical path method, PERT, program evaluation and review technique, and RPWM, resource planning and workflow management, determine start and end times. All three methods help determine the start and end times of each activity. This is critical for setting a realistic project timeline. Dependency relationship between activities. Both CPM and PERT focus on understanding how tasks are interdependent. Coming towards the critical path determination, CPM and PERT both emphasize determining the critical path of the project. Estimating project completion probability. PERT and RPWM allow for estimating the probability of project completion by considering the uncertainty in task duration. Managing delays and resources usage. CPM and RPWM are designed to manage delays by allowing resource optimization and effective task allocation, ensuring that the project moves forward efficiently. In summary, these methods offer different approaches to scheduling and managing construction projects, with each focusing on key elements. In this section, I'll explain the methodology we follow to mitigate the delays in construction projects, focusing on technologies and risk management practices, as well as how Microsoft Project can be leveraged for effective project scheduling. Methodology overview. Our methodology includes several key technologies and practices aimed at mitigating delays and improving project management. Vertical tracking and planning helps to track progress in real time, identifying bottlenecks early, and enabling project managers to take corrective actions swiftly. Lean construction aims to eliminate waste and optimize resources. Coming towards the last planner system, it enhances project scheduling by focusing on collaboration and detailed planning at every stage, reducing delays caused by lack of coordination. Risk management, a critical component, involves identifying and addressing potential risks that could delay the project. We have developed a framework for assessing and mitigating these risks, categorized as technical risk, financial risk, legal risk, political risk, social and economical risk, environmental risk, resource related risk, planning and management risk, design risk, natural risk, and quality risk. Each risk is assessed in terms of probability and consequences to prioritize mitigation efforts. The table on the right demonstrates a risk matrix, which helps evaluate risk based on likelihood and impact. The matrix ensures that resources are allocated efficiently to address the most critical risks. Coming towards the Microsoft project for project management, the table on the lower left presents an overview of the Microsoft project schedule for case study project, outlining the key phases of the project from inception to operation. WBS work breakdown structure, we have broken down the project into six major phases: inception, procurement of consultant, design phase, construction phase, completion, and operation and maintenance. Microsoft project is used to ensure the project remains on track by enabling accurate scheduling, task tracking, and resource management. It also helps identifying critical paths and potential bottlenecks, allowing project managers to make timely adjustments. In this section, we will discuss lean construction, a methodology aimed at maximizing value while minimizing waste, and the application of key techniques like the last planner system and value stream mapping in project management. Additionally, we will explore the concept of tech time calculation for improving work efficiency. Lean construction focuses on eliminating waste and optimizing process in the construction projects. The approach centers around continuous improvements and better resource management, allowing projects to be completed faster and more efficiently. Last planner system is a key part of a lean construction. It involves the following planning stage: master planning, developing an overall project plan; phase planning, breaking down the project into phases for better management; look ahead planning, ensuring that each phase is properly prepared and ready to begin. Coming to the commitment planning, having a clear commitment from all stakeholders for the execution of tasks; continuous learning, constantly reviewing performance and improving project planning processes. Coming towards the weekly PPC technique is used to track and evaluate the weekly completion status of tasks in a project. It provides a percentage that reflects how much of the planned tasks have been completed according to the schedule. The PPC formula is number of works completed on the particular week which have been planned to be completed on that week divided by number of works planned to be completed on that particular week into 100. The table in the slideshow weekly PPC for 6 weeks showing completed tasks, tasks not completed, and the percentage PPC. For example, week 1, 88.89% of tasks were completed as per the planned schedule. Week 4, 100% completion was achieved, indicating no delays for this week. This approach helps in measuring how project is adhering to its schedule and guides resource allocation and task prioritization. Value stream mapping is another tool used in a lean construction to optimize project workflows by identifying and eliminating waste. Current state mapping. This phase involves analyzing the current workflow to identify any inefficiencies or bottlenecks, identifying any elimination of waste. This step focuses on recognition of the type of waste in the system and eliminating. Coming towards the type of waste, one is defects, another is defects is rework due to errors, then is extra processing, unnecessary tasks that do not add value, then is motion, unnecessary movements of workers or equipments, another is inventory, excess materials or supplies that are not immediately needed, then is transport, unnecessarily movement of materials or resources, then is waiting, delays waiting for materials, information or workers, then is non-utilized talent, underuse of workers' skill or capabilities. By identifying these waste projects can be made more efficient. Coming towards the tech time calculation, tech time is the maximum time allowed to produce a product in order to meet customer demand. In construction, it helps determine the pace of work to ensure that the tasks are completed efficiently. For example, in the case of AAC block machinery, the tech time calculated is masonry work 30 square meter per block. One mason and one helper can complete 380 square meter in height, with each taking 480 minutes. The tech time for each square meter is 60 minutes. This calculation ensures that workers know how long they have to complete each unit of work and helps manage their productivity on site. In the final section, I will summarize the key takeaways from our research on improving construction project outcomes. Advanced tools like Beam, Primavera, and MSP are enabling real-time progress tracking and support informed decision making that can allow for timely adjustments in project management. Coming towards the lean construction, by eliminating inefficiencies and improving supply chain management, lean principles ensure that projects are completed faster and within fewer resources, leading to cost savings and enhanced productivity. Coming towards the planning and scheduling, the last planner system has been instrumental in improving scheduling, reducing delays, and fostering collaboration. By focusing on realistic planning, continuous monitoring, and stakeholder commitment, LPS helps ensure tasks are completed on time by boosting their project efficiencies. Vertical tracking. Vertical tracking provides a clear view of discrepancies between planned and actual progress, help to identify delays and their causes such as resource issues or external disruptions. Thank you.